from here I'm going to launch the runner tool. And basically the runner tool, like I said earlier, is the execution tool. And essentially what happened is when I launched it, it automatically created the test plan for me, so all of my test steps are listed on my screen. And I need to make sure that my controller is set up correctly. So the controller is the hardware piece in between your target board and the PC. So you'll have, we have USB controllers, we have PCI controllers, PCMCIA controllers, Ethernet controllers, so on down the list. So in this case, I'm using a net USB box with a USB interface. I have my T clock frequency set to 10 megahertz, so everything looks good there. And then I need to make sure my board's powered on, and it is. So I'm going to go ahead and just run this test. Ask me if I want to overwrite or append to the log file. I'm just going to overwrite it. And we can see it very quickly passes through the list of tests that we generated. So it did an infrastructure test, the interconnect, the bus wire, the resistor test, the memories, and the flash tests. And total execution time is down here at 2.5 seconds. Now, it's great to see everything pass, but you want to understand how our tools provide you the information or indicate the information to you when a board fails. So what I'm going to do is flip one of those switches on the board and show you how it fails. So I flipped a switch S6. Now before I actually run the test, I'm going to go into the schematic and do a search for S6 so that we can get an idea of what we expect the failure to be. So S6 is a normally open switch, so when I flip it, it closes this and creates a short. That short happens between this net SDRAM data 2 and SDRAM data 3. So if I run the test, it should show me a fault in that area. So we can see it did fail. Now I need to look at that failure. And basically it says, okay, I found an interconnect test fault. It's a bridging fault, and it was detected between these two nets, SDRAM data 2, SD data 3. Tells me where the most likely areas of this short occurs, and then also what devices are on those nets, whether they be boundary scan pins or non-boundary scan pins. You can also look at the test vectors that were executed. So this is a list of all the test vectors that were executed, and we can just scroll down and see a huge number of them. You can also filter it down to if you only want to see the failed nets. You can filter down even further if you only want to see the failed pins. You can also identify the vectors in a graphical format. So if you're more comfortable looking at waveforms as opposed to ones and zeros, that feature is also available to you. So that's a bridging fault. What I'll do is also inject another fault for an open. And again, what I've done is I'm going to do a search for S8. Okay, so S8 is down here. Now this is a normally closed switch, so when I flip the switch, it opens this circuit, and I can see that this goes to pin 20 on my Xilinx CPLD, which is reference designator U5. So when I run the test, it should show me that U5 pin 20 has been opened. So I ran it again and it failed. I double click that failure and I can see, okay, my interconnect test failed again, fault detected on net data bus 2, receiver U5 pin 20 is open or stuck. So that's pretty much the advanced diagnostics capability. Now you can also from here